Okay, driving back to the house after dropping the kids off. Thought I'd have a little discussion about two different items on topic, and these two items are dark energy and dark matter. Now, the question is, what is the universe that we know actually made up of? The reason that this is such an interesting question is because literally we don't really know what 95% of the universe around us is actually made of. If you break it down into a 100% pie graph, you would have a pie graph with about 75 or so, 74 I think percent of the universe made up of something very mysterious called dark energy, and about 20 or so percent made up of dark matter, which we understand a little bit more than dark energy, but we still really don't understand it at all. And then there's, somewhere between 4 and 5% of the matter that we can actually detect. Now, first off, dark matter. How do we know that it exists? Well, the reason that we know that dark matter exists, which we're starting to call WIMPs, W-I-M-P-S, which is an acronym for Weakly Interacting Massive Particle. Okay, and when we say weakly interacting, it's very weakly interacting. It only interacts, so it seems, with one of the four major known forces of the universe. Out of electromagnetic force, you've got a weak nuclear force, a strong nuclear force, and gravity. Gravity is by far, far, far and away the weakest of the four known forces, and that's the only one that it seems to interact with. And we know that it interacts with gravity because the stars moving towards the outside of any galaxy that you look at are moving at about the same speed or even faster than the stars that are in close to a galaxy toward the center. Now, what's wrong with that is if you think about it, in terms of our own solar system, obviously, if you've seen it, Mercury, the closest planet to the sun, it's moving very, very fast because it's very, very close to the sun and it's in a tighter orbit. Whereas Neptune takes hundreds of years to go across, or to go around the sun one time, and moving very, very slowly. Basically, as you go, like planet by planet, the further out you go, the slower that planet's going. Well, we just thought if we observed other universes that the same physics would apply, but it does not. The stars on the outside are moving just as fast or faster than the stars moving that are moving in towards the galaxy, and that doesn't really make any sense to us. So we call our solution is to say that there exists something called dark matter. We don't detect it whatsoever. We don't detect it directly whatsoever at all. We detect it indirectly because of its influence on gravity on these stars. So there must be some type of weakly interacting massive particles out there, and it makes up about 20% of the universe. Now, dark energy. Yeah, this makes up about 75% of the universe, and we absolutely have no idea what this stuff is, not even close. The only reason that we know that it exists is because the expansion rate of the universe. Now, when they finally had, I don't remember the guy's name that got the Nobel Prize for figuring this out, he went about calculating what the rate the universe was expanding at. Well, everyone in the astronomical community, everyone just assumed that the universe was still expanding, but it was definitely slowing down, and that's due to gravity attracting other objects. So there's a stronger pull on gravity on these objects to eventually move closer to one another. That's not what we found out at all. We actually found out that the universe is accelerating as it moves outwards in every direction. This goes against all laws of known physics, all of them. We just call it dark energy because we really don't have another name for it. The only thing that's detectable so far about dark energy is that we know that there's some kind of force that is working opposite to what gravity is doing, and we don't understand it. It's kind of like you're here on Earth and you take an apple, you throw it up, or a baseball, whatever, and the baseball comes down, but due to gravity, well, in the case of dark energy, you throw the apple up in the air and it just keeps on going, and it doesn't even pay any attention to gravity. That makes up 70% of the known universe. So basically, lesson for today, we've had a couple hundred years of astronomy and astronomical findings, and we know what about 4% of our entire universe is at the moment. We know absolutely nothing. Thank you very much.